Alright, so the other method that we're going to talk about that uses algebra to help us solve a system of equations is elimination. In elimination, our goal is the same regardless of the approach we take, and that is that we want to create an equation that only has one variable in it. Now, when we used substitution, we got that done by 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 rearranging one of the equations and substituting an expression into the other equation so that we only had x's or we only had y's. So our goal is the same in the long run, and that's to create an equation with only one letter. We're just going to take a different approach. So our first step in elimination is that we're going to make the coefficients of one of the variables into opposites. We're going to make the coefficients of one of the variables into opposites. And so let's start by starting at the end of that sentence and make sure we work our way back, that we know what they are. When we talk about opposites, in math class we're talking about a number that's the same distance from 0 but in opposite directions. So the opposite of positive 12 would be negative 12, and the opposite of negative 3 would be positive 3. Okay, so same distance from 0 but opposite signs, opposite directions. The coefficients are the numbers out in front of the x and the y. So up here the x coefficient is 2, and down here the x coefficient is 1. The y coefficient is negative 1, and the y coefficient here is positive 4. So we want to create a situation where we have opposites with one of those variables. Again, any place you have a 1 or a negative 1, you're going to focus on that variable. And since we have each here, it doesn't matter which one we work with. Okay, I'm going to say let's just go with the x's because they're out in front. Now the way that we're going to make these guys into opposites is we're going to multiply both sides of our equation through by a constant. So, and I know I'm allowed to do that as long as I do the same thing to both sides. So I have a positive 2x up here in this equation. The opposite of positive 2 is negative 2. And so if I multiply the 1x times negative 2, that would make a negative 2x on the bottom. Now the top equation didn't change. The bottom one, if I multiply every piece of both sides through by a negative 2, I have negative 2x, I have negative 8y, and a positive 2. So once we've done that, and sometimes we only have to change one equation and sometimes we change both. Okay, but after we do that, we add the two new equations together. If we add these two equations together, notice what happens here to the x's. And this is why we needed opposites. The x's are going to go away, and my new statement says negative 9y equals positive 9. So while we had a different approach, we still accomplished that first goal, and that's to create an equation that only has one variable in it. Now from here, once I have an equation that only has y's in it, I can solve, actually I'm going to come back here if I can find my mouse. Okay, we can solve this guy for y in one step. Once I know that y is negative 1, I can come back to one of the top equations. It doesn't matter which one. I can solve it for x. I can find out x equals 3. Once I know the y and I know the x, I put them in the correct order, x comma y, and I leave my solution written as an ordered pair. Steps 3, 4, and 5 in elimination are the same as in substitution. Okay, step 3 is solve for y. Step 4 is plug it back into the beginning and get the x. Step 5 is write your solution as an ordered pair. Let's try it again with the other system that we worked with in the last video. Alright, on the last example, it didn't matter whether we were wanting to get rid of x's or y's. It was the same number of steps to get here. Okay, notice if I wanted to make opposites out of my x's, I would have to change both equations. Okay, 2 and 3 aren't multiples of each other, so I would have to go up to like 6 and -6 and change both. But because I have this 1 here in front of the y, I can easily make it into anything I want to. Because this is a positive 3y right here, I'm going to multiply both sides by -3 to make this into a -3y. So negative 9x minus 3y equals 21. The bottom equation we didn't have to change, not when we took this path. When we go to add the two new equations together, okay, notice the y's go away this time, and we're left with an equation that only involves x's. When I divide now to get the x by itself, I have one step to my x. Once I know what x is, I can plug it into either original equation and solve for y. And then I can write my final answer as an ordered pair. Now, when you're doing the homework from this section, make sure you follow the directions. On a test or on a quiz, I will not tell you which method you have to use. I will let you choose whichever way you like best. Okay, however, you have to know how to use it correctly. Okay, in the homework exercises, when it asks you to use one of the methods, even if you like the other one better, you'll only get points for using the method that the book asks. Okay, I need to see that you know how to do and you've practiced both methods. And then when it comes time to test and assess, then I'll let you choose which one you like best. Okay, we'll start another video to talk about our other special cases, because so far the examples, we've done them over and over again, but the examples we've done have all had one solution. Okay, and I know there are still two other options. So we don't yet know what it looks like to have one of these two situations. So the next video, we'll talk about inconsistent and dependent systems.